Welcome to today's paper reading. Today's paper is titled, On LLMs-Driven Synthetic Data Generation, Curation, and Evaluation, a Survey. This survey paper, published in the Journal of Clinical Trials and Healthcare Analytics, is authored by Lin Long and colleagues from Zhejiang University and Harbin Institute of Technology. In the context of deep learning, the challenge of balancing data quantity and quality has persisted. Real-world data often falls short, necessitating the use of synthetic data. Large language models, LLMs, offer a promising solution through synthetic data generation. However, current research in this area is fragmented and lacks a cohesive framework. This paper organizes existing studies based on a generic workflow for synthetic data generation, identifying gaps in current research and suggesting future directions. The aim is to guide both academic and industrial communities towards more systematic and in-depth investigations into the potential of LLMs-driven synthetic data generation. The emergence of large language models, LLMs, has brought about a significant shift in the field of deep learning. Despite these advancements, high-quality data remains crucial for building robust NLP models. High-quality data typically refers to diverse data with rich supervision signals aligned with human intent. However, relying on human data for this purpose can be challenging due to high costs, data scarcity, and privacy concerns. Additionally, human-generated data is susceptible to biases and errors, which may not be optimal for model training. This necessitates exploring more effective and scalable methods of data collection. Given the capabilities of LLMs to generate fluent text, synthetic data produced by LLMs emerges as a viable alternative. Synthetic data mimics the characteristics and patterns of real-world data and can enhance the efficacy and controllability of model training. This makes LLMs highly promising as synthetic data generators. Figure 1 illustrates the ecosystem of LLMs-based applications, where synthetic data acts as the essential nutrients. These nutrients are utilized for two main purposes: fruiting, which involves the training of small language models, LLMs, or fine-tuning task-specific LLMs, and rooting, which pertains to the training of stronger LLMs or their self-improvement. This ecosystem highlights the critical role of synthetic data in enhancing the capabilities and adaptability of LLMs across various applications. In this paper, the authors investigate the generation of high-quality synthetic data using pre-trained large language models, LLMs, denoted as M. The generation task is formulated as GenMP, T, sup, where Gen is the final generated dataset, P is the prompt, T specifies the generation task, and sup represents seed samples or unlabeled inputs. The requirements for high-quality data include faithfulness, ensuring logical and grammatical coherence, and diversity, capturing variation in text. Prompt engineering plays a crucial role in enhancing the quality of synthetic data by specifying tasks, using conditional prompts, and providing in-context demonstrations. Figure 2 presents a taxonomy that categorizes the process of generating synthetic data using large language models, LLMs. The taxonomy is divided into three main topics: generation, curation, and evaluation. Each of these topics addresses specific challenges and methods to ensure the quality and diversity of the synthetic data. The generation aspect focuses on creating data that is both logically coherent and varied, while curation involves refining the data to improve its quality, and evaluation assesses the effectiveness of the generated data. This taxonomy aims to provide a comprehensive framework for understanding and improving LLMs-driven synthetic data generation. The generic workflow for synthetic data generation driven by large language models, LLMs, involves three main stages: generation, curation, and evaluation. In the generation phase, techniques such as prompt engineering, multi-step generation, and conditional prompting are employed to create diverse and high-quality synthetic data. The curation stage focuses on filtering out low-quality samples and enhancing labels, either through human intervention or using auxiliary models. Finally, the evaluation stage assesses the generated data through direct metrics and indirect methods like benchmark and open evaluations to ensure its suitability for downstream tasks. Figure 4 illustrates the two primary methods of data curation: high-quality sample filtering and label enhancement. High-quality sample filtering aims to eliminate low-quality samples using heuristic criteria or reweighting functions. Label enhancement methods focus on correcting erroneous annotations in generated samples, either through human intervention or by using auxiliary student models for knowledge distillation. Additionally, heuristic metrics and sample reweighting are employed to assess and adjust the importance of data samples, ensuring the dataset's quality and relevance for downstream tasks. In the future, addressing complex tasks will require more systematic approaches to decomposition. Current models struggle with limited information and multi-step reasoning, necessitating a deeper investigation into these areas. Enhancing knowledge within LLMs is crucial to mitigate biases and improve data quality. This can be achieved through automated condition controls on domain knowledge bases. Additionally, synergizing large and small language models can enhance data curation and generation quality. Real-time feedback and diversified collaboration modes are key to this improvement. Figure 5 illustrates the direct and indirect methods of data evaluation. Direct evaluation involves using ground truths from existing datasets for automatic assessment of LLMs generation results, which is ideal if available. For open-ended data, human-based evaluation is necessary, where human experts determine the correctness of generated samples to estimate overall generation quality. The quantification of data diversity primarily uses vocabulary statistics and sample relevance calculations, with vocabulary statistics providing a straightforward approach and sample relevance capturing semantic information more effectively. In this paper, the authors present a systematic review of advancements in synthetic data generation driven by large language models, LLMs. The objective is to offer guidance to enterprises and organizations on effectively building their domain-specific datasets using LLMs. The paper also highlights the challenges and opportunities in this field and proposes potential directions for future research. However, the study has limitations, focusing mainly on text data and LLMs-driven approaches, with plans for future work in other fields. The authors emphasize the ethical implications of synthetic data generation, highlighting the potential benefits for researchers and industrial producers, but also the ethical concerns and the need for vigilance against malicious use. Thank you for watching.